In this video, we are going to see everything in and around the linked list, its types and operations. First, we can see what is a linked list. It is a linear data structure which looks like a chain of nodes where each node is a different element. Unlike these arrays, these linked list elements are not stored at contiguous location. So it is basically chain of nodes where each node contains information such as data and a pointer to next node in the chain. So in this linked list, there is a head pointer which points to the first element of the linked list, and if the list is empty, then simply it points to null or nothing. So this is about the linked list, which is a series of nodes which contains data and a pointer. So next, why this data structure is needed, that it is dynamic data structure. So the size of the memory can be allocated and deallocated at runtime based on the operation of insertion or deletion. And in linked list data structure, it is easy to insert or delete an element. That is, it is simpler than arrays since no element needs to be shifted after insertion or deletions. Just the address need to be updated. So we go for this linked list data structure. And efficient memory utilization. As we know, linked list is a dynamic data structure. The size increases or decreases as per the requirement. So this avoid the memory wastage. So then implementation, various advanced data structures can be implemented using linked list like stack, queue, graph, hash maps, etc. can be implemented using this linked list data structure. So these reasons we go for this linked list data structure. And now we can see the types of linked list: a single linked list, double linked list, and circular linked list. So these are the types. You can see them one by one. And first we are going to see the singly linked list. So the traversal of items can be done in the forward direction only due to the linking of every node to its next node. So this is called the singly linked list. And we can see the operations which can be performed on this singly linked list. Insertion can be performed in the following ways: inserting at the beginning of the list, inserting at the end of the list, and inserting at specific location in the list. And deletion can be performed in the beginning and in the end, and deleting a specific node. And search, it's a process of determining and retrieving a specific node. And display also can be done in this singly linked list. This process displays the elements of the singly linked list. So these are all the operations that can be performed in the singly linked list. First, we can see how to insert a node at the start or beginning of the linked list. Here we are having a series of nodes A, B, C, and D. And now we are going to insert the node E at the start of the linked list. And you can see how we can insert. First, we can make the node E as the first node of the linked list, and you can remove the head from the original first node of the linked list. That is the head pointer which points to the head of the list. Before it pointed to the node A, which was the first node in the linked list. Now we can remove the head from the original first node of the linked list, and then make the new node as the head of the linked list. This is how we can insert a node at the start of a singly linked list. Now we can see how to insert a node after a given node in the linked list. And now we are having the nodes A, B, C, and D, and we are going to insert a node E. We can assume that the given node is a B, which is the TMP. That is, we can insert B, after the node B, and to make the element to be inserted as the new node, and change the next pointer of the given node to the new node. And Now shift the original next pointer of the given node, that is the node B, to point to the new node. So this is how we can insert a node after a given node in the linked list. And now we can see how to insert a node at the end of the linked list. For this we can go to the last node of the linked list, change the next pointer of the last node from null to the new node. We already know the last node points to a null. If it doesn't have a node after that, so always the last node will have a null pointer, next node as the null. And so here we can change the next pointer of the last node from null to the new node. So since we are inserting the node at the end of the list, and then make the next pointer of the new node as null to show the end of the linked list. And the process of deletion in a singly linked list also follows the same procedure of changing the pointers. So I'm not going to say that. And now we move to the doubly linked list. In this traversal of items can be done in both forward and backward directions, as every node contains an additional previous pointer that points to the previous node also. Till now we saw only the singly linked list which points only to the next node only. So here the traversal of items can be done both in forward and backward directions, since it has an additional previous pointer. So the nodes will be like this. It has a previous pointer and also a next pointer and the data. And we can see the operations on this doubly linked list also. Insertion can be followed, can be done at the beginning after a given node, and inserting at the end and before a given node also. And deletion can be performed in the beginning, end, and deleting a specific node, and displays the elements of the doubly linked list. So we can see them one by one. And first we can add a node at the front of in the doubly linked list. For that, first allocate a new node. Now put the record data in the new node and make the next of the new node point to the current head of the doubly linked list. That is, the next pointer should point the current head, that is, before the head was A. So this new node should now, the next pointer of the new node should point to the head of the A, which was first in the doubly linked list, and make the previous of the current head to point to the new node. So the previous pointer of A should point to the new node, and then the point head to the new node. So now the head pointer should point to the new node, which is the E node. And this is about the addition of a node at the front of a doubly linked list. And now we can move to the addition of a node in between the two nodes. This is further classified into two parts: adding a node after a given node in the doubly linked list, and also adding a node before a given node in the doubly linked list. So we can see them on. Now we can see the first scenario, that is add a node after a given node in the doubly linked list. We are given a pointer to a node as prev underscore node, and a new node is inserted after this given node. These steps include 5 following steps, where the prev underscore node points to the, that is a pointer which points to node B. So we are going to insert a new node E after the given node B. And firstly, we can create a new node, that is E. Now we insert the data in the new node and point the next of the new node to the next of the prev underscore node, that is previous node, that is previous node, which indicates the node B, and now we can point the next of the new node, next pointer of the new node to point to the next of the previous node, which is the node C, and then point the next of previous node, that is next of B to the new node. So if this is done, and then point the previous of the new node to prev node, that is the point the previous of new node, that is the previous pointer of the new node should point to the previous node, that is node B, and then change the pointer of the new node's previous pointer to new node. These are the steps that we have to do to insert a node after a given node. Now we are going to this next scenario. Add a node before a given node in the doubly linked list. Let the pointer to this given node be next underscore node. This can be done in the using the following steps. Now we are going to insert a node B before a node C. That is this is given as the next node, that is node C is given as the next node, and before that we are inserting the new node B. Now we are going to allocate the memory for the new node, that let it be new node, put the data in the new node, and send now set the previous pointer of this new node as the previous node of the next node, that is which is the node A, and so we are going to set the previous pointer of the new node as the node A, which is before the previous pointer previous node of the next node, that is C. Now we are going to set the previous pointer of the new node to point to the node A, and now this set the previous pointer of the next node as the new node. Now we are going to set the previous pointer of the next node, that is node C, as the new node. Now set the next pointer of this new node as the next node. If you follow the diagram, you can understand that. So please follow the diagram when I say. And now set the previous pointer of the new node, and if the previous node of the new node is not null, that is if the previous node of the new node is not null, then set the next pointer of this previous node as the new node, and else if the previous of the new node is null, it will be the new head now, so it will be the starting node. So like this we are doing, and now we can move to add a node at the end in the doubly linked list. So we have finished that both scenarios of adding a node before and after a given node. Now we are moving to a scenario that adding a node at the end of the doubly linked list. Now create a node and put the value in the node. Make the next pointer of the new node as null. Since we are adding the node at the end, if the list is empty, make the new node as the head. Otherwise, travel to the end of the linked list. And now make the next pointer of the last node to the new to point to the new node, and change the previous pointer of the new node to the last node of the list. Now we can move to the deletion part. Deletion is done like this, that is this is given a example list. Now after the deletion of the head node, then if the node is 45 is before the node, that is node 2 is the head node, that node 2 is deleted, And now if it is deleted, the list will be like this. The pointers will change like this, and then after the deletion of the middle node, that is a middle node now is the node 3 which is deleted, and after that the linked list looks like this with the pointers. And then after the deletion of the last node, the node 45 alone remains with the pointers. And now we move the circular linked list. This circular linked list is a type of linked list in which the first and the last nodes are also connected to each other to form a circle. That is, there is no null at the end. This is the difference between the so that is other linked list. So this is a type of list in which the first and the last nodes are interconnected. That is, they form a circle and then there is no null at the end. So now we can see the operations at this linked list also. The insertion that can be performed is in an empty list at the beginning of the list and at the end of the list, and also between the nodes. And deletion can be performed from the beginning of the list and the end of the list, and also deleting a specific node. And this displays the data in the circular linked list. And then we move to the insertion in an empty list. Initially, when the list is empty, the last pointer will be null. And after inserting node T is the last node. Now where the point is that we are inserting in an empty list. So if we insert a node T, then T is the last node, so that the pointer last points to the node T. So, and node T is the first and the last node, so the T points to itself. So, since there is no other nodes in the list. Now we are going to insert at the beginning of the list, and we can insert a node T that is with the number 10 to the beginning of the list. The diagram after insertion is given first. That is, originally the list has node 6 and 8. Now we are going to insert a node T which is the node 10, and first the last pointer of the that is the next pointer of the last node, that 8, that points to the node 6. That is the initial diagram. And now we are going to insert a node 10, that is T, at the beginning of the list. And now the node T is inserted at the beginning. That is the first diagram. Kindly follow that. And now to insert at the beginning of the list, we are following the steps. Create a node say T, and make the that is next pointer of the T node, that is last node, as the last node's next node. That is before the last node's next node will be the node 6. Now this node is made as the next node of the node T. And now if you follow the diagram, you can see that. And last, that is the next pointer of the last node, is now the node T. And this is about the insertion at the beginning. And now we can see the insertion at the end. Now we are going to insert a node T, which is inserted at the end. And now the following changes are made. Make the next pointer of the node T as the next pointer of the last node, and then the next pointer of the last node is the, now it is made the node T, and now the last node is the node T. So this is about the insertion at the end. Now we are going to insert the particular node between the nodes. To do this, create a node, say T, and search for the node after which the T needs to be inserted. That is node 8, which is known as the node P, and now make the next pointer of the T to point to the next node of the node P. Next pointer of the node P, and now the T is made as the that is next pointer of the P node is made the node T. And now we can see with the example. Suppose a 12 needs to be inserted after the node 8, which is node P, and now the pointer is changed like this. Then after insertion, we can see the pointers are changed like this. We can observe that the and then we can move to the deletion part, deleting first node from the singly circular linked list. First, if we delete the first node, the list will be changed like this, and then the after deleting this first node, that is the linked list will be changed like this. Now we can move to deleting the last node of the circular linked list. If I ignore the first diagram, now if the node 44, that is the last node is deleted, then the next pointer of the last node will point to the first node, or that is the node 99, which is the last node. Now it became the last node since the node 44 is deleted. And now deleting nodes at a given index. That is, if we delete a node at the number 22 that we want to delete, then the pointers will change like this after deleting. And these are the various operations that can be done in all the three types of linked list. Now we move to the applications of linked list. And list of songs in a music player is linked to the previous and next songs. So for this the linked list can be used. And in a web browser, previous and next web page URLs are linked through the previous and next buttons. And in the image viewer, the previous and next images are linked with the help of the previous and next buttons. In mobile phones, we save the contacts of people. The newly entered contact details will be placed at the correct alphabetical order. This can be achieved by a linked list to set contact at the correct alphabetical position. So these are the applications of the linked list. Subscribe to my channel if you feel contented. Like and share my videos with your friends.